installment of Salt Air. Now, I know our backdrop is missing. We haven't set it back up since the last conference that we've been to, but there's still a lot to talk about, still a lot to do. Now, we put up a Salt Air episode yesterday, which was very brief, and did a quick demo of Salt.ssh. Now, Salt.ssh is just one of the really big and exciting features that have come in the 0.17 release of Salt. Now, I'm going to spend a little bit of time talking about the 0.17 release of Salt, talk about some of those highlight features, and call out some of the community members who have once again done fantastic work inside of Salt. 0.17 is the biggest release we have ever done by leaps and bounds. And now I'm kind of wondering why this screen share button isn't working. Cute. All right, so what we're going to do here, there we go. Now, hiccup over. Now, what we're going to do here is talk through some of the new features in Salt 0.17. Now, there's a couple of really important things that I should bring up. This is the biggest Salt release ever. What we're looking at is well over 3,000 commits to the Salt codebase for 0.17, and this was roughly 3 months in the making, which again is the longest time we've ever had between major feature releases. Gotta make another big thanks to the community. These new features that we've got into 0.17 are massive and extensive, and I really regret the fact that we don't have the opportunity to talk about everything that's been added, because it's, again, very extensive. So we're going to highlight a lot of the major features, and we're going to talk about those. Now, something else to keep in mind is that Salt still is the largest developer community in DevOps. We have the largest active contributor base. We have the largest total contributor base. The best place to check this is to go do some comparisons on Olo. But things are massive. We keep growing. We keep getting bigger. There are more and more and more people in our community, and I can't stop thanking how everyone who contributes to and works on Salt makes us what we are. I'm also really excited to say that one of the big things that we've got in the pipe, or it's out of the pipe, one of the big things that we have now is the Salt Web UI Halite. And Halite is completely open source. And so, once again, we are staying open source. We're not going open core like I've been saying this whole time. So let's start talking about some of these features. Now, we come and we look at Halite. Halite is a truly asynchronous UI that is completely event-driven. Some of the things that are great about Halite is that since it is truly event-driven, it can handle the massive concurrent inputs that we get when we're running a Salt system. So it plugs directly into Salt's internal event bus and is able to display information that's coming from all the events that are being passed in. So this advanced state control inside of Halite allows us to do remote execution in a really clean way. Now, on top of this, in Halite, we are actively working on getting job controls going, advanced state management, and then working more towards abstracting a lot of the features of Salt into the UI. One thing that we're really excited about with the Halite UI is the fact that there's a lot of functionality inside of Salt that we don't really get recognized for, that we're not as publicly known for. We're mostly still publicly known as a config management tool, but we're getting more and more and more users out there who are using Salt for things like auto-scaling, cloud management, cloud integration, monitoring, continuous code delivery, things of this nature. Now, the next thing I want to talk about is Salt.ssh. Now, Salt Air 6 has a fantastic demo of Salt.ssh in the works. Now, I'm going to answer a couple of questions that were posed about the Salt Air 16 that we put up yesterday. But Salt SSH, everything is over SSH. It's the only transport that is used. No 0MQ is required. You don't need to so much as install it. How Salt SSH works is that it takes a new piece in Salt called Salt Thin. Salt Thin is that we can now execute Salt without any of the transport or crypto dependencies. And so Salt itself can be completely detached and just dropped somewhere and executed. And so that's what Salt SSH does. It drops a Salt package, a Salt Thin package on remote systems, and then is able to use Salt call to execute routines. It has full support for remote execution and full support for Salt states. So you can do everything that you can do with Salt with respect to those areas using Salt SSH. Now, there's a number of things that it can't do quite yet because, well, we keep developing it. But we do have a lot of this excitement coming down the pipe with Salt SSH as far as adding new features and continuing to make it capable of doing a lot of the more advanced stuff that Salt does. Now, of course, it's nowhere near as fast as Salt over 0MQ, but we were really excited yesterday when we were putting together some of those final at-scale tests and executing Salt SSH over 100 servers to see just how fast it really is. We were still able to communicate with 100 machines out on Rackspace and DigitalOcean. And again, big thanks to Rackspace and DigitalOcean for letting us spin up all those systems. But it was still able to communicate with those systems in seconds. And sure, that many systems Salt over 0MQ should be able to communicate with in less than a few seconds. But we were still able to get that information out there. So Salt SSH is really exciting. Now, one other thing that was asked in the notes of the last one about Salt SSH was, where do we get the information about the targets that we're hitting? And we do that via the roster system in Salt. And the roster system allows us to define where targets are. Because inherently, Salt, with 0MQ, the minions just need to be aware of the master. The master doesn't need to be aware of where those minions are because they connect with a TCP connection. But Salt SSH, your originating server, needs to know where all of your target systems are. And so you do that by defining a roster. Now, the roster system is pluggable, like everything else in Salt. And since it is pluggable, you can write your own rosters, which means you can generate this information from a database. You can generate this information from, well, virtually any source that you need to. All right. Now, the next thing that I'm really excited about here is State Auto Order. Now, State Auto Order is another addition onto the state system, which is really powerful. What it does is it makes it so that states are evaluated in the order in which they are defined in the SLS files. So that means that states will always execute in the order in which they are defined in the SLS files. It does this by embedding order flags inside of the states as they get rendered. So what this means is that you can have a complete assurance as to the order in which everything's going to execute. Now, Salt has always executed its states in a finite order. It's always executed them in the same order every time that they're run. But in the past, we've been completely dependent on manually setting the order flag inside of states or using Salt's declarative engine. Salt has and still maintains a completely declarative engine, which is extremely powerful. But the State Auto Order system makes it even easier. So how this works, I'm going to have another Salt Air coming out that describes it in a little more detail, but existing states are unaffected. There are no changes need to be made to handle this new feature for all of your existing states. The declarative hooks inside of Salt still take precedence over anything else. What this does is it defines the evaluation order. And again, I'm going to describe that in a little more detail in Salt Air 18. Now the next thing is the State.sls Runner. This is really new, really shiny, but still a little rough around the edges. This is a new runner inside of the State Runner, which is made to really upgrade the capabilities that you have from the overstate. And so what happens with the State.sls Runner is that you're able to execute the state system on the master to call out to routines on minions, which makes it extremely easy to have the full power of SALT's state system to orchestrate large-scale deployments. And so this is a very substantial upgrade from the capabilities of the overstate. Now, one of the nice things here is that there's no new interface to learn. It's all just still writing SALT formulas. There's a number of things that are still rough around the edges, particularly in the realm of how information is output. Some of the things that we're working on for the next release of SALT have to do with getting intermittent returns from minions when they're running state routines, so that we'll be able to visualize all of the individual executions that are happening as they happen out in the wild on all of your systems, and be able to monitor and view those in a massively parallel fashion. But so that's coming, and that's going to really bolster this State.sls runner. Now, I mentioned Salt Thin briefly a few moments ago. Now, Salt Thin is really cool because what it allows you to do is have just this tarball of the dependencies to just run Salt's execution libraries and the state system locally. And so Salt Thin was created to facilitate Salt SSH, because we create a Salt Thin tarball and we drop it on those target systems and then drop over just the states that we need to execute them and then fire it off. But Salt Thin is completely detached, and so you can generate a Salt Thin tarball and then drop it wherever you'd like and just run Salt. So there's a new runner called the Thin Runner, where you can execute and it'll print out to the display where your Salt Thin tarball is. And then again, you can just drop it somewhere. It comes with Salt Call is inside this tarball. You can execute that Salt Call script and run Salt routines anywhere without needing to otherwise install Salt. Another great thing about Salt Thin is that it is pure Python, so you really can just drop it anywhere that you have Python 2.6 or higher. Now, there's a bunch of other fantastic things that have been added into this release that I just don't have time to go into right now. And there's a number of these that, again, haven't been mentioned. But our good friend Pedro, or SoundTech, has added an external pluggable logging system, which makes it extremely easy to drop in logging additions that allow Salt to automatically go out and log to any back-end interface. So those systems can be made to log to something like Splunk or New Relic or whatever you'd like. The new Django ORM external pillar, we just got that squeezed into 0.17, and so that allows you to abstract pillar data directly from a Django ORM style database. The Mercurial file server backend comes in and it works much like the Git file server backend, but now we can do it with Mercurial, which is going to make a lot of people happy. Now, we've got the ability to hook into StormPath's authentication system natively inside of Salt now. I'm excited about this because StormPath is picking up a lot of steam, and we've gotten to know them, especially when we bump into them at a lot of those conferences. So a big shout out to StormPath. They're doing a great job, and they're getting a lot of people using their service. But so now Salt can directly authenticate its user interfaces with StormPath. So, StormPath. Now the new roster system is really cool, because the roster system is another plugin system that's made to back up Salt SSH. But the roster system, what it does is it allows you to generate all of the information that you need about where target systems are for Salt SSH to hit. Now we've got a couple other ideas in the pipe that are going to make use of the roster system. Right now there's 2 roster systems inside of Salt, and we're looking forward to getting some more in here. But these roster systems are the flat roster system, which is the default. It just uses a YAML file, which you can put Jinja into. The flat roster system does use the render system inside of Salt, so you can use YAML and Jinja, YAML and Mako, or any of those sorts of things to represent the data that's being rendered. But the other roster system is called the scan roster system. What the scan roster system does is it allows you to scan individual IP addresses or subnets and look for OpenSSH ports, and then get a list of all of those systems with OpenSSH ports, and Salt SSH can then try to attach to them. This can be a fantastic way to just point Salt SSH at a subnet and say, salt me that subnet. Now, I've mentioned this before on the mailing list, but we do have Jenkins.saltstack.com up. I'm really excited about this because Jenkins.saltstack.com is allowing us to finally have continuous full platform testing. And this is something that we're, again, really excited about. We've also able to get full pilot and Pepe testing up on Jenkins so that we can keep the code base not only functional and well tested across multiple platforms, but also extremely clean, and keep that code nice and shiny. And it helps us follow up with our policy of saying that you give us a pull request that works well, we will merge it, and then we'll see where the pilot and Pepe issues are, and we can all get those fixed, instead of us sitting in an ivory tower and saying that you can't give us code until it's perfect. We are more than happy to help people make their code fantastic. We've also seen substantial LXC integration additions. Now, one of the things that we're working towards is the ability for Salt to maintain clouds via LXC systems to a much more powerful degree. We already have support for running Zen and KVM very well, and so we're excited to keep seeing more of these additions come in. Now, the next thing that I want to mention here is that we are about to change how our versioning works, but only slightly. New releases of Salt after the .17 release will follow date-based versioning. Now, the reason for this is that it's abundantly clear that the versioning numbers that we're using are irrelevant to what the underlying Salt code really looks like. They're not relevant to the maturity of the code or the capabilities or feature sets or anything of that nature. They're just arbitrary numbers. And so the next release is going to be the last 2 digits of the year, followed by a dot, then followed by the month of that release, and then that will be the feature branch. And so if we come out with a release in November, then that release will be 13.11.0, and then the maintenance releases for it would be 13.11.1, .2, .3, .4, and we keep the 11 even if we have a maintenance release in February of 2014. And then the next feature branch that we come out with would be the date of that feature branch coming out. Now, the only problem that we run into here is that now we have to introduce code names because we're not entirely sure what the next release number is going to be, since we don't always get things released on the month that we originally planned. And so we've decided to follow the periodic table for all of our code names, which means that you now know our code names out for quite a while. So the next release will be codenamed Hydrogen. We're still going to refer to them via their release numbers, but it's just an easy and convenient way for us to keep track of saying what is the release that we're currently working on without declaring exactly what that date is going to need to be. All right. So, a lot of exciting stuff is coming in .17, and we've still got a lot of exciting stuff that's going to be coming in the next release, or Hydrogen, as I just said. And so, keep tuned. We keep working on Salt. We continually are infinitely grateful for all of the help and all of the contributions that we continue to get from our community, and again, why we stay open, why we care about being open, and why we believe that being an open source company and an open source product and an open source project is what really drives innovation and what really drives us to deliver to our users and our customers exactly what it is that they need, instead of us trying to create everything inside of an isolated bubble. But so until the next salt air, stay salty.